A dwarf planet 4 billion miles from the sun is running its own private refrigerator, cooling itself down using nothing but a thin blue haze floating in its own sky. Nobody expected a world this small, this cold, and this far from anything to be doing something like this. And the scientists who just confirmed it are calling it a genuinely new kind of climate, one that doesn't match anything else we've ever studied anywhere else in the solar system. Here's the number that makes this strange. Pluto sits roughly 4 billion miles from the sun. Sunlight reaching its surface is about 1,000 times fainter than the sunlight hitting Earth right now. Surface temperatures generally run between negative 387 and negative 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. By every basic rule of physics, a world that cold, that thin, and that far from any real heat source should behave in a simple, predictable way. Instead, new data confirms Pluto is actively pulling extra heat out of its own atmosphere, using a mechanism that took scientists 8 years and an entirely new space telescope to actually prove. I'm going to walk you through exactly what NASA and an international team of researchers just confirmed about Pluto, using real published research, not exaggerated headlines. I'm the host here at Today Latest Analysis, and we break down real space discoveries the way the actual scientists explain them, not the way clickbait does. Subscribe now, because there's more coming out of the outer solar system, and you don't want to miss it. Let's go back to where this story actually begins, because Pluto's history is stranger than most people remember. In 1930, a 24-year-old assistant named Clyde Tombaugh, working at Lowell Observatory outside Flagstaff, Arizona, was assigned one of the most tedious jobs imaginable. Photograph the same patch of night sky on different nights, then flip back and forth between the plates, searching for a single point of light that had shifted position against the fixed stars behind it. Most nights produced nothing. Then, on a set of plates taken in late January and early February of that year, something moved. A tiny dot had shifted, and that dot became Pluto. For the better part of a century afterward, it held the title of the 9th planet in our solar system, even though it was so distant and so small that astronomers could only guess at what it actually looked like up close. Then in 2006, the International Astronomical Union held a vote and formally reclassified Pluto as a dwarf planet, stripping it of the title that had made it famous. Part of what forced that vote was the discovery, just 1 year earlier in 2005, of a distant object named Eris, initially estimated to be even larger than Pluto itself. If Pluto counted as a full planet, astronomers realized they would eventually have to start adding dozens of newly discovered objects to that list as better telescopes kept finding more of them. Instead, the IAU created a formal 3-part definition of what a planet actually is, and Pluto failed the final test. It hadn't gravitationally cleared the neighborhood around its own orbit the way Earth or Jupiter has. Pluto remains the only world in recorded astronomical history to be discovered, celebrated for 76 years, and then formally voted out of the very category that once defined it. For a long time, that felt like the end of the story. Pluto was small, distant, and easy to file away as unimportant. That assumption did not survive contact with real data. It's worth pausing on just how little we actually knew about Pluto before any spacecraft ever visited it. For most of the 20th century, even the largest telescopes on Earth could only resolve Pluto as a tiny, blurry smudge of light. Astronomers could track its orbit fairly precisely, but its size, its surface composition, and whether it even had an atmosphere remained genuinely open questions for decades. Some early estimates wildly overstated its size, based on gravitational effects on Neptune and Uranus that later turned out to be measurement errors. Not real influence from Pluto at all. Much of what the public believed about Pluto for generations was built on guesswork stacked on guesswork, which makes what happened next even more remarkable. NASA's New Horizons spacecraft launched on January 19, 2006, roughly the size of a baby grand piano, carrying a small container with some of Clyde Tombaugh's ashes on board, a quiet tribute to the man who discovered the world it was traveling 9.5 years and more than 3 billion miles to reach. On July 14, 2015, New Horizons flew past Pluto at more than 30,000 miles per hour, passing within roughly 7,800 miles of the surface. It had exactly one chance. No orbit, no second pass, just a narrow window of a few hours to capture as much as it possibly could before continuing on into the darkness of the Kuiper belt forever. What it sent back completely rewired what scientists thought they knew. A massive, pale, heart-shaped plane, now officially named Sputnik Planitia, stretched across the surface, smooth and strangely young-looking compared to the ancient, heavily cratered terrain surrounding it. Mountains built from solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like solid rock. Fields of nitrogen ice appeared to be slowly churning in giant convection patterns, hinting at heat and motion happening beneath a crust scientists had assumed was completely dead. and layer after layer of blue haze rose more than 300 kilometers, close to 200 miles above the surface, visible even when backlit by the sun, far higher and more intricate than anyone had predicted. Pluto did not look like a leftover chunk of frozen rock. It looked like a world still in the process of becoming something. But New Horizons only got one look. It captured what it captured and kept flying deeper into the outer solar system, never to return. Whatever it missed on that single pass would remain a mystery for years. What researchers needed next was not a better photograph. They needed a way to read Pluto's chemistry directly from billions of miles away without ever sending another spacecraft. That's exactly what the James Webb Space Telescope was eventually able to do. Here's what makes Webb fundamentally different from a spacecraft like New Horizons. Webb doesn't fly past anything and snap a picture. It reads light itself, breaking it apart into individual wavelengths to reveal the precise chemical and thermal fingerprint of whatever it's staring at. Pointed at a faint pinprick of reflected sunlight billions of miles away, Webb can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how that atmosphere behaves over time, all without physically traveling anywhere. The technical challenge here is worth appreciating on its own. Pluto and its largest moon, Charon, sit so close together in the sky from Webb's point of view that separating their individual thermal signals used to be practically impossible with earlier telescopes. Researchers working before Webb launched had repeatedly tried to detect a specific heat signature coming from Pluto's haze, and repeatedly came up empty, not because the signal didn't exist, but because their instruments simply couldn't tell how much of the detected heat was coming from Pluto itself and how much was bleeding in from Charon sitting nearby. Webb's mid-infrared instrument, known as MIRI, paired with a 5-meter primary mirror, more than twice the width of Hubble's, finally solved that exact problem, allowing scientists to cleanly isolate Pluto's own thermal signature for the first time in history. Starting around 2022, once its instruments were fully calibrated for this specific target, Webb turned its attention toward Pluto. And what's come back since hasn't simply been a prettier picture. It's been closer to a full diagnosis, revealing behavior so unusual that researchers are still working out exactly how to explain some of it. The first major finding involves that same blue haze New Horizons first photographed back in 2015. Researchers already knew Pluto's thin atmosphere was wrapped in a delicate shroud of hydrocarbon particles. What nobody had confirmed was exactly what that haze was doing to the world underneath it. Back in 2017, a planetary scientist named Shi Jiang, working at the University of California, Santa Cruz, proposed an idea that sounded almost backwards at the time. On Saturn's moon Titan, atmospheric haze traps heat and warms the world below it. Jiang argued Pluto's haze might be doing the exact opposite, absorbing sunlight during the day and then radiating that energy straight back out into space as infrared heat, faster than Pluto's extremely thin atmosphere could ever hold on to it. In effect, the haze wouldn't be acting like a blanket. It would be acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, this idea struck many of Jiang's peers as unlikely, and there was no instrument available yet capable of actually testing it. That changed once Webb's MIRI instrument became sensitive enough to separate Pluto's faint thermal signal from Charon's, something no earlier telescope had ever managed cleanly. A team led by astronomer Tanguy Bertrand at the Paris Observatory used that instrument to measure Pluto's atmosphere directly across multiple wavelengths, 15, 18, 21, and 25 micrometers, tracking how the heat signature changed as Pluto rotated. The results, published in the journal Nature Astronomy on June 2, 2025, confirmed almost exactly what Jiang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze particles suspended within it, and the effect turned out to be roughly 30 degrees Fahrenheit colder than earlier models had expected. The same study also confirmed a second separate prediction made in 2023 by Jiang's former graduate student Linfeng Wan about exactly how strong Charon's own light curve signal should look if this haze theory were correct. Two independent predictions, made years apart, both confirmed by the same dataset. Bertrand himself described it plainly, saying this is unique in the solar system, a genuinely new kind of climate that shares no obvious playbook with any other world we've studied. Researchers now believe similar haze-driven climates might exist on other hazy worlds too, including Neptune's moon Triton and Saturn's moon Titan, and some scientists suspect early Earth, long before oxygen filled our skies, may have looked something like this as well. There's a second discovery tied to that same haze, quieter, but just as strange once you sit with it. Even the extremely faint trickle of sunlight reaching Pluto is enough to break apart methane molecules high in its atmosphere. Those broken fragments don't simply vanish. They recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles called tholins, which drift downward and settle onto the surface below. New Horizons caught early traces of this process back in 2015, and Webb has since helped refine exactly how it unfolds. Here's the detail that tends to stop people in their tracks. Tholins belong to the same broad family of organic molecules some scientists believe may have once rained down onto early Earth, potentially contributing raw material for the chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years, a slow, continuous snowfall of biological building blocks landing on a surface far too frozen for any of it to ever spark into something alive. The third major finding is the one that tends to unsettle people most once it's explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this was happening, but for a long time, nobody knew exactly where all that escaping material was actually going. It wasn't simply vanishing into empty space. Something was catching it. Pluto's largest companion, Charon, roughly 750 miles across, orbits in an extremely tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else visible on the Moon. For years, researchers suspected a connection between that coloring and material escaping from Pluto, but lacked the tools to confirm it directly. The mechanism turns out to be tied to Charon's extremely slow, extremely long seasons. Because of how Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time. That makes the pole an extremely effective cold trap, a place where escaping methane molecules drift in, freeze solid onto the surface simply because there's no warmth to keep them as gas, and sit there accumulating for years before sunlight finally returns. Once sunlight does return, it doesn't simply melt that frozen methane away. Ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, locking in that dark coloring permanently rather than letting it evaporate back into space. Two worlds, locked together in a slow, ongoing exchange of atmosphere and color, apparently running quietly since long before either one had a name. This exact interaction, atmosphere escaping one body and painting the surface of its neighbor, has no known equivalent anywhere else in the solar system. Charon had one more surprise waiting too. In October of 2024, a team led by researcher Silvia Protopapa at the Southwest Research Institute used Webb's near-infrared spectrograph to confirm the presence of both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to disinfect a wound frozen directly onto Charon's surface. According to the published research in Nature Communications, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. Protopapa noted this specific combination of frozen chemicals had never been confirmed on Charon before, adding another layer to a moon that keeps turning out to be far more chemically complex than its plain icy appearance would ever suggest. Now picture for a moment what it would actually be like to stand on Pluto's surface. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth. You could look directly at it without discomfort. The sky around it would sit in a permanent grayish-blue gloom, thick with haze, never fully day and never fully night. The ground beneath your feet wouldn't behave like ice does here on Earth. At nearly 400 degrees below zero, water ice stops being slippery and behaves closer to solid rock, hard enough to ring almost like metal if struck. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving since the two worlds are close enough in size and locked tightly enough that each one always shows exactly the same face to the other. The surface holds its own separate mysteries. In a region named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system. Tall rows of jagged ice blades, some reaching more than 900 feet high, made of frozen methane and arranged in long parallel ridges. Far smaller versions exist here on Earth in certain high-altitude deserts, where they're known as penitents and rarely grow taller than an average person. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator. Elsewhere, south of Sputnik Planitia, two enormous isolated peaks rise from the landscape, one roughly 13,000 feet tall, the other close to 20,000 feet, both with deep depressions at their summits resembling cooled lava flows, except there's no molten rock on Pluto. If these are what they appear to be, they're cryovolcanoes, structures that once erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from beneath the icy crust. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today: the possibility of a hidden liquid ocean buried roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. The evidence isn't a photograph, it's a pattern. Cracks and ridges across the surface, lining up the way you'd expect from a subsurface layer of liquid water shifting slowly beneath the crust, with Sputnik Planitia itself sitting directly above what appears to be a positive gravity anomaly. Similar hidden oceans are already strongly suspected beneath Europa and Enceladus. If a body as small and cold as Pluto is hiding something similar, buried oceans may be a far more common feature of icy worlds than scientists previously assumed. There's currently no funded mission planning to send another probe back to Pluto, largely because the journey alone would take the better part of a decade, and outer solar system exploration has rarely been treated as a funding priority compared to faster, closer missions. For now, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings into its field of view, adding another data point each time. Pluto sits inside the Kuiper belt, a vast ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects, and an estimated trillion or more comets, an area of space hundreds of times larger than the asteroid belt between Mars and Jupiter, and almost entirely unexplored. Only one spacecraft, New Horizons, has ever ventured deep enough to closely photograph any of its larger residents, managing close flybys of exactly two objects, Pluto and a smaller, more distant body nicknamed Arakoth. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of new questions scientists are still learning how to properly ask. If one small, frozen, formerly dismissed dwarf planet was hiding this much complexity, it's genuinely worth wondering what all those other distant, unstudied worlds might be hiding too. If stories like this one, grounded in real published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications. Because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Drop a comment and let me know what part of this surprised you the most. Share this with anyone who'd find it genuinely fascinating, and I'll see you in the next one.